Okay. Yeah, we are on live. Let's go. So, hi guys, this is Chris from DoraHacks. Welcome to another ETHVietnam Finalist product demo sessions hosted by DoraHacks. It is a great pleasure for DoraHacks to support ETHVietnam for the very first time. This time, we simply divide the hackathon into just two tracks, which are existing project track and new ideas track, and also with a wider range of bounties provided by leading projects in the industries. In the end, we have received more than hundreds of project submissions, and we verified 80 projects of those. And today, we are very happy to have three finalist teams with us. They are ZkForm, Social Recovery DAO, and Shinka Wallet. Before we start, keep in mind that every team will have no more than 15 minutes for presentation, including Q&A part. So don't make it too long and complicated. Also, for all the audience, if you have any questions for any of the teams doing the product demo sessions, please feel free to ask in our YouTube room. We will ask those questions for you for the teams. So first team, ZkForm, feel free to begin when you're ready.
All right. Quickly share my screen. Can anyone see my screen now?
Yeah, we can see.
Cool. Hi everyone. My name is Chi. I'm from ZkForm, and these are our teams. We are made of Kung, Bunkang, Sheng Yong, and of course me myself. And this is a project born from the recent ETHVietnam hackathon. And thank you ETHVietnam and DoraHacks for giving us the opportunity to come up with this project. So what exactly is ZkForm? Allow me to present you with a problem statement. So just imagine on my screen we have this thing. We have a medical cert. Now a typical medical cert looks like this. We have the medical history, the blood type, medication. You have whether or not you are a medication allergy or not. And I'm pretty sure there are a lot more other stuff. But for simplicity, let's just have these four details. What we can see is that some of these things are rather private. We definitely do not want to share them to the public. But what happens if, for example, in this case, an insurance agent were to request some details from you from the medical cert? You have no choice but to give them the entire form, and without your permission, the insurance agent is able to scrutinize the entire form, even for the details that they do not need. That means we are potentially leaking a lot of a lot of private details to a third party, and we definitely do not want to do that. So imagine now, back to our form. Imagine now what happened if, for example, we only want to share our blood type and not the other details. We are able to hide stuff from our medical certificate. So imagine that you have your medical certificate, and then you just put you just white out the parts that you don't want to share, and then you are able to share this form to the insurance agent. For example, like this, you're just whiting out the part that you don't want to share, and the insurance agent is then able to trust that, hey, the cert that you just gave them, it's valid. That means it comes from a hospital, and the details are correct, and you're also not revealing the private data that you don't want to share. So how do we achieve that? So with ZkForm, we use zero knowledge proof protocol, and to be exact, we use Hello 2 by the Zcash team, and by doing so, we are able to achieve exactly what I just stated a moment ago. A couple of implementation details as to how we achieve the privacy, achieve ZkForm. So the step number one is that we need the hospital to generate a commitment hash for each file that they are hashing, and we have this thing called a two-way hashing, which is horizontal hashing and the vertical hashing. So let's start off with how it looks like. So for horizontal hashing, we split the form into like a title and a content file, like this. What we do is that we take the hash of the title and content for each row to produce a horizontal result hash for each row, just like that. So we perform that for every row, and then the vertical hashing will just be like long tail hashing, or like a accumulated hash, whereby for each of the row we just hash these two rows, and then the result of these two rows will be hashed against the third row, and so on and so forth, to form a final accumulated hash. So this final accumulated value will then be our commitment hash, which will then commit to the blockchain just like this. So the intuition behind this is that the moment we change any of this field over here, the hash, the intermediate resultant hash will be changed, and then ultimately it will change the final accumulated hash. So what that means is that if you try to alter any of these values, that is without any of these values, we will affect the final committed hash here. And let's look into this function over here. So this is a function on a smart contract on the blockchain. That means that it is transparent and it is immutable. And we can only see that in this case, only owner can commit file hash. So in this case, only the hospital is allowed to commit the file hash. So what's going to happen over here is that finally, at the end of the at the verifier stage, the verifier will compare the hash with the commitment hash that he or she is getting with the one that is committed on the blockchain. So that means if I were to tamper my file, the hash committed on the blockchain will be very different from the one I'm getting, from the one that the verifier is getting. So this is how we are able to confirm that the file is untampered with. And so how do we generate proof? And how do we select show data that we want while hiding other data and generate proofs for that? So this is a simple diagram of our prover. So we have like a prover, and then there's a public and private input. So private inputs are inputs that you do not want to leak, which is the file details. The file details is the entire content of the form, and the selector, which is the row that we want to review. And these are private, and this will not be revealed to the verifier, which is in this case the insurance agent. And the public input will be the commitment hash, because this will be used by the verifier to confirm that if it matches as the one that is updated here in the blockchain. And also the selected rows, which is the data that we want to review in plain text. So what the prover does is that it checks if the file details properly hashes to the commitment hash. It ensures that the execution of this thing is correct. And then the selector, it consists of only 0 and 1s, because we put it in such a way that is Boolean. So and of course the selector row is contained within the file detail. So these are the stuff that is done by the prover. And once these are valid, it will then generate a proof, which will be sent to the verifier. So the proof alongside with the public input, which is these two, will be sent to the verifier, and the verifier can check if the proof is correct. And there's one step. The verifier will also check if the commitment hash matches as the one that is committed on the blockchain right here. So once everything is done, the verifier, which is in this case the insurance agent, is able to confidently say that, hey, the medical cert indeed comes from a hospital, and the content, which is the row that we are showing here, is untampered with. So just let me give you a quick video demo of how it looks like from our POC. So the first step involves creation of proof. So creation of form. So what it does is that we are able to fill up the form. This is in this case the hospital, just like that, able to add rows and stuff. And then this is the address of the certificate owner. And once we have that, we are able to create form. And in this case, what we are trying to do is that we are submitting the commitment hash and commit it to the blockchain. And this is done by the hospital, which is the certificate provider side. So once everything is done, we are able to get the form and share it to the certificate owner. So what's going to happen with the certificate owner? The certificate owner will just need to upload the form, just like that, and select the row that he or she wants to share, and then generate the proof. This will take a while, but once it's done, we are able to get the proof in a file, which will then be passed on to the insurance agent, just like that. So all the insurance agent need to do is to drag and drop the file onto an interface. And for this case, we are showing all the details that is relevant, which is the contract address that the commitment hash is committed to, the verifier address, which is in this case the owner, the selected from and content detail, which is the one that we want to review, and this is the proof, which is just a huge number. In this case, it doesn't make sense, but it's here for completion. And once the verifier has everything, all you need to do is to click on verify proof to check that if the proof is correct. And yeah, there you go. Once the verifier has received this success result, he or she is able to trust that the form is untampered with. Let me quickly jump over the steps here. So what we plan to have for ZkForm is to have a very generic structure. In this case, we are using it for hospital purposes, but we definitely see a potential use case in finance and academic industry as well. For example, in academic industry, what happens if you only want to share our CGPA publicly while not revealing how long it takes for one to graduate, or even the subjects that one takes to obtain that CGPA, because those are probably irrelevant and we want to keep them private just in case. So we can also use them, in this case, we can use ZkForm for universal certificate. For other things like financial reports, if you want to, for example, hide a certain proof to someone that, hey, we have indeed performed a transaction while hiding other more sensitive transactions, probably related to a trade secret, we can do that with ZkForms as well, and potential other use cases. So future plans, because this is a very generic protocol or infrastructure, we want to make it to be an SDK, so anyone can easily spin up ZkForm for his or her own purposes. We also want to improve on the proving time. As you can see, the sped up video took a while to generate proof. We want to make it faster so that the experience of users can be better. And there are a couple of features that we want to add. For now, we are just reviewing stuff in plain text. What we can do afterwards is to perform like a range check, so that, for example, we are able to prove that, hey, my CGPA is more than 3.5 without exactly telling you the exact value of my CGPA. So with that added feature into ZkForm, we are able to perform slightly more other things, and definitely other more features as well. Cool, and that sums up my presentation. Thank you for having me, and thank you all for listening.
Yeah, thank you very much, Chief, for this very detailed introductions. It definitely looks really interesting. In the beginning, I thought that it might be like a project that be applied in the future healthcare industries, but it seems like you have more plans that it can be applied into multiple industries. So definitely looks very exciting. So we'd love to know a bit more about like your team background. You mentioned a bit more about like the future roadmap. Also, would love to know a bit more about that. Like what's your plan in the next probably half years, 6 months, or whatever that you think might be helpful for us to better understand.
Cool. As for team background, we are 4 devs who just like building, and we hop on into the zero knowledge rabbit hole. And Kung Wong Kang and Sheng Yong and me, we know each other from real life. That means we formed this team and we decided to join ETHVietnam together. So I think that, and we just love building like a ZK zero knowledge protocol, and ETHVietnam just presents the perfect opportunity for us to do that. We have 1 month to research and 1 month to build, and it's good to see that we managed to do that on time. On future plans, yes, definitely we plan to work on these 3 features, SDK and stuff like that. So what can be easily done right now is the SDK. We are able to allow people to easily spin up their own version. We plan to continue working on that in the following weeks or so. Right now, everyone is busy from traveling and stuff like that, and that is. And one particularly interesting thing that I personally would like to push is this range check for private inputs, and because that requires us to write new circuits. That means a little bit more R&D and stuff like that. So I think I do not know if I answer your question, but these are the couple of things that we like to work on.
Yeah, definitely answer my questions. We have actually a couple grants program that might fit your interest for the for your next couple months development for the project. It might be helpful for a project, so we can discuss later after the demonstrations. But yeah, it's a great pitch.
Thank you. Appreciate it.
Thank you, team. Yeah. So yeah, let's welcome the next product today, which is the Social Recovery DAO. Dev, not sure if that's your real name, but feel free to start when I'm ready.
Can you see my screen?
Yeah, we can see.
Okay, cool. So, hello everyone. My name is Devraj Singh Rawat, and I am from Social Recovery DAO team. And I would like to thank the whole ETHVietnam hackathon team as well as DoraHack. Those has organized this wonderful event and given us a chance to build something useful for the Web3 community. So let me give a context behind our idea and why do we think it can be useful uh, in the key management and maybe in future user onboarding when user will feel more comfortable using the Web3 products. So yeah, I will start my slide with a famous or infamous crypto dilemma where everyone says if you don't have, it's not your keys, then it's not your coins. So everything in blockchain controlled using the keys, basically the seed phrase which we need to preserve to own our assets as well as recover our asset. Some way it's a virtue of the Web3 world that it this seed mechanism gives the power back to the user, but as well as many of us comes from the traditional way of trusting the institutions where somehow people has a tendency to trust the third parties to keep their passwords or their accounts or their asset to be secure. So, okay. So, this dilemma is creating a big problem for many new user as well as many, experienced user, because losing a key is like, it's not predictable. Anyone can lose their key, no matter if he is a beginner or he is an expert user. Even we use hardware wallets and other kind of security wallets. Every most of these wallets are also recovered or are also backed up using the seeds. So this was a known issue in the blockchain space. So to overcome this issue, many attempts has been made, and one of those attempts were made by Argent as well as Gnosis Safe. These both of these companies are a smart contract based wallet. And if I give you a brief idea about how these wallets work and what these wallets are, basically these wallets acts as a intermediary to route your transaction to the Ethereum. So we can say that these wallets, these wallets or safes can hold your funds, like they can hold your Ethereum or any assets, ERC20 assets, maybe other assets as well, which are NFTs, and they define, like we can define the roles within these smart contracts. Like we can say that these two addresses I approve as a day limit of 1 Ethereum. So whenever a transactions come from those two specific addresses, the wallet will check whether what is the limit of these two accounts who had signed this transaction. Basically, this transaction is also called as meta transactions. And when they check, okay, what is the value associate with this transaction. They say this is it is less than 1 Ethereum or maybe 1 Ethereum. Then they checks their limit, and based on that, they further execute that transaction. In the similar way, these smart contract wallets can be they can be guarded using the recovery module. So if I just talk in terms of Gnosis, so Gnosis safe, we can plug in multiple modules in the Gnosis safe, and one of the module can be social recovery module. In that module, we can define many of our friends and family and the threshold. So I can say that address number, 1 2 3, like those addresses must be, address of my friend MetaMask wallet, or maybe their hardware wallet, or maybe their other any trust wallet. So I can mention that address, and I can also mention the address of, my close family members. And when the time comes, suppose I lose my device, who is the owner of this particular Gnosis safe. So suppose this is the owner, like this is a dummy owner called 1234. Suppose this is the my device private public key. And when I lose my device and I didn't back up my seeds, that means I don't own the private key associated with this 0x123. So in that case, what I can do, I can I can create a recovery transaction and ask, all the recovery agents which I have mentioned in the recovery module. So in this case, in this example, I have shown 0xR1, R2, and R3. I can go to these guys, any two of these guys, because the threshold is 2 by 3. So I can send them the recovery transaction. They can sign on that recovery transaction and give back to me. And once I get that recovery transactions, all those recovery transaction, I can push those recovery transaction using my new wallet. And when the safe sees the recovery module sees that the the recovery transaction are signed by the recovery agents mentioned in the this array, which is part of this recovery module. In that case, it verifies, okay, these guys are genuine who had signed on this recovery transaction, and then it replaced the owner with the new owner who had submitted this recovery transaction. So this is the brief history, like how this smart contract wallets work. Now, the issue in this process, like this is a great concept, and it is definitely added a value into this smart contract, or as well as Web3 ecosystem. But the issue is, like all the addresses which I'm adding here, they might not be the very professional in key management, and they can also lose their key. There is hardly any incentive for them to maintain their key properly. So many times, when we go back to our recovery agents, it is highly possible that they themselves lost their keys and they cannot able to sign with that particular key. And in that case, it is a big failure for this whole social recovery module. So to overcome this thing, and to reduce the risk of losing the key and adding an incentive, or I would say, managing this key in a decentralized manner, where people have incentive to provide a recovery signature to someone who had requesting for these services. So for that purpose, we come up with this idea called social recovery DAO. So in this idea, what will happen? uh, we will have a DAO, social recovery. In that DAO, there will be some users who want their keys to be back. They want their keys to be back up by some of the recovery agents, and there will be some other members who are ready to provide their services. And this DAO will make sure that this signing services is happening in a decentralized way, and people the service providers will have a reason to maintain their keys. Like they will have a incentives. It could be a time bound incentive, or it could be a signature bound incentive. So let me start a demo to make you understand it more better. Just a minute. Okay, let me take the demo from the DoraHack website. So yeah, so this user can log in into this portal using their Ethereum key, Ethereum login, and then so this enroll me section will have the all the service providers who had registered into this service. Right now, these service providers are just hard coded some defined Ethereum addresses, but in future we will be having a module where these guys will either enroll using some soul based NFT, or they will be joining by using proof of humanity, where we will be implementing some DID based mechanism. The DID based, we are preferring a DID based service, which is a zero knowledge based DID, where this service provider can provide their information for the to get the credentials for the login. And after this, these service provider will get their membership for the DAO. They have to stake some amount of Ethereum or as any DAO currency for to check their behavior. If they do something, they do not serve the request properly, or they does not behave as per the rules defined by the DAO, they will be slashed. Okay, so in the enroll me, user will come here and user will see, okay, what is the fees for this particular service provider for providing the services and how much the rating is. This rating is right now it is static, but it will be there will be another module which will define the rating based on the stake they have done in the DAO, as well as the number of signature they are providing in the frequent basis. And after that, user will come here, user will select the specific service provider, user will put any identifier. Right now we are putting identifier as a wallet address, but this could be any identifier which can uh, map the identifier and the service provider. Now this service provider will go and log in. The service provider will get a notification using Ethereum push notification, or maybe maybe some we will implement some email or SMS notification based on the details this service provider has provided to the platform or provided during his DID based verification. And once he get the notification, he can come and log into the service, where he will see that there is a service request for enrollment, and someone is seeking his signature services from the DAO. Then this person, the service provider, can approve or reject that request. If he approves, a notification will send back to the user that your request has been approved, and then user will log in to his using his uh, using his MetaMask account, and he can see that service has been approved, and then he will confirm this service provider. Once this user confirms the service provider, that the details of this service provider and that mapping key which we had provided at the enroll me section, which was wallet address that time, it will be hashed and stored in the smart contract. And then user can also see that in many time user can see who all are service provider protecting his wallet. You can see from this section, you can see, okay, we are also planning to add few more details here, that how frequently this, what is the last login of this service provider on this portal. All those information can give a better idea of to user, that how active his service provider is. And if he sees that service provider is not very active, he can delete the service provider and add a new service provider. Then this user lost his key, and definitely he will log in with the new user. When he log in with a new user, he cannot see any reference for his wallet in this select wallet section. Then he will provide that reference uh, which he had used during his registration time. And right now we have kept it as his old address. And after he provide the reference, he can see which wallets are associated with this user, and he can then request for the signature service. He can say, okay, this is the service provider who is guarding, who can provide me the recovery signature. He will click on the recovery, like request signature, and here he will input the recovery message, or we can say recovery transaction. Uh, yeah, after he submits this request, a notification will go to the service provider, and a request will be created for the user. And then service provider will log into his system. And once service provider sees that there is a signature request pending for him, he can generate a signature for this user. And yeah, this will fetch the recovery transaction. And once user says done, it will create a user signature and stored in the backend. We are not storing the signature right now on smart contract. Yeah, it will be just stored in the backend, but yeah, we can improve this process in future based on the number of signatures being created. Now user can see that the request has been signed, and he can click on retrieve signature. Once he click on the retrieve signature, he has to pay for the signature, and there will be on-chain transaction where the fees associated with this signature will be attached in this transaction, as well as the data, which is a signature, will be passed to the smart contract. Smart contract will verify the signature, whether the signature is signed by the correct service provider. If the signature is signed by the correct service provider on the correct message, then this fees will be transferred to the service provider, and user will able to retrieve the signature. And yeah, right now it's a dummy signature, but yes, the signature will be, whatever signature is stored in the backend will be retrieved here. And then after that, user will able to get all the number of signature he was supposed to get from this portal. And then he can club those signature, and that is an off-chain process. He can club those signature, and he can pass those signature into that social recovery module of safe or any other smart contract module. And he can then initiate his recovery process. uh, so yeah, this is the demo. And what next we are working on this solution. We are still need to implement that service provider onboarding, where we will use proof of humanity. We will preferring any zk zero knowledge did based solution, or solve based nft solution. We are researching on Polygon ID, which is also a zero knowledge DID solution, where service provider can provide information in zero knowledge way and get registered to the service. We also need to implement this incentive layer and the governance layer for to work to make sure this DAO can be governed in a decentralized way. Yeah, that's all from my side, and thank you again.
Thanks. Thank you very much for the presentation. Due to the time limitation, we won't have enough time for you for the Q&A part, but it's a great pitch. Yeah, thank you. Thanks. So yeah, let's welcome the last but not the least project today, which is the Shinka Wallet. Taiju, yeah, feel free to start.
Okay. Oh, okay. So I'm now sharing my screen. So can you see my screen?
Yeah.
Okay. So Shinka Wallet. So let me talk about the Shinka Wallet. Shinka is I'm from Japan. I'm Taiju, and Shinka means the evolution, like evolving, like a Pokemon from Pikachu to Raichu. This is Shinka in Japanese. So why we use Shinka? Because we are going to evolve your EOA wallet, like MetaMask, into Super Wallet. So we use the account abstraction internally. So we use ERC 4337. So we build the bundler and paymaster contract and entry point contract, smart contract wallet. And we use account abstraction to make your EOA as function as Super Wallet. And the problem I want to fix in this hackathon is like obstacle with current L2. So some of you might use L2 like Polygon ZkEVM or Scroll, but in current situation, using L2 is a bit tough because maybe gas price is cheap, but you have to bridge your token to L2 and then wait some time to get bridged. And then finally, you can start using the L2. So maybe if you are familiar with crypto, it's easy. But for the new user, it's too much complicated. Like my friends, they don't have a MetaMask or they don't have cryptocurrency. For them, it's too much difficult to start using the L2. So we are talking about L2 is good for scalability, but too much obstacle for new users to join the L2 space. So now I propose the Shinka Wallet, and Shinka Wallet is the account abstraction wallet, and also account abstraction paymaster infrastructure for L2. So in this hackathon, I focus on the development on paymaster. So, but I think the paymaster and account abstraction stuff is a bit complicated and difficult to explain. So let's dive into the demo. So this is the demo I post in the YouTube, and you can also check this demo in the DoraHack portal too. Okay, so let's play the demo. So basically, this Shinka wallet is a browser-based wallet, so you can access in browser or your mobile browser too. And this browser wallet, you can connect MetaMask like this. And then this mobile wallet, you can connect apps through Wallet Connect. So this part is so fast. So I stop. Okay. So now I connected. I'm using the Shinka wallet, the mobile wallet, and then connect to the sample example wallet, sample example dApps provided by Wallet Connect. And then this Shinka wallet is about the contract wallet. This is more like safe, Gnosis safe, because Gnosis safe is a contract wallet, and Shinka wallet is also the contract wallet. And my contract wallet is using the account abstraction interface. So now my contract wallet has a deposit function, but my project purpose is to fix the obstacle to join the L2 space. So we have an off-chain payment method in the contract wallet. So let me do the demonstration. So in this Shinka wallet, you can pay gas fee by payment token or Ethereum and also credit card. So let me do the credit card payment function. So let me check it. Yeah. So for payment, I integrate the Stripe. So, but this is tested environment, so you don't have to worry about the $100. This is the test money, and this credit card number is also dummy number. But I integrate the Stripe to make it happen with the off-chain payment. So this is the payment process, and then when I finish the payment process, so currently the credit card balance is 0.08 ETH, but wait for some time, it gets synced. Yeah, we got the one more 0.08 Ethereum. This is equivalent to the $100 just now I paid by credit card. So let me explain the backend process. So currently I'm using a Stripe. So when user make the payment in the Stripe, the payment information is sent to the Stripe backend. And also Stripe has the backend process to process the webhook. So when user make the payment information comes to the my backend through the webhook. So this is the webhook. And then my backend process the payment information. So just check the customer information and payment information and the amount. And then my contract is going to send the information to the smart contract. And my smart contract process the payment amount. And also my smart contract has the integration with the Chainlink Oracle. So we check the $100 is equivalent to 0.08 Ethereum in the current Chainlink price Oracle feed. And then finally, we process the deposit process in the Paymaster contract. So now our Paymaster contract has the deposit for users to process the transaction. So now user doesn't have to care about the Ethereum cryptocurrency, just using the credit card. And then users contract wallet is funded with the off-chain payment. So now I can do the demonstration of sending transaction with Shinka Wallet. So this is a dummy transaction from the Wallet Connect sampled apps. So this is a simple transaction, just sending the no value to the certain account. So let me do the demo. Basically, when we do this transaction, user have to have the cryptocurrency in the wallet. But now we are using Shinka Wallet with account abstraction, and we use the Paymaster contract to skip the gas payment. So now user can make the transaction with no gas fee. So this is the kind of specific transaction in account abstraction. So let me check it. Okay. So now the transaction is sent to the backend bundler, and the backend bundler processes the transaction instead of the user's EOA. Okay. Yeah, this is like this. And let me check the token transfer information. So this is the actual bundler, which is broadcast the transaction. So this is the backend smart contract. Backend EOA. But this EOA is actually making the transaction. So, but this EOA is paying gas, but this gas fee is payback to bundler account from the Paymaster contract and the entry point contract. So, which means user is paying the gas fee off-chain by credit card. Let me check it. Yeah, this process. So user is paying gas fee by credit card off-chain, and the deposit is stored in the Paymaster contract. And then user just sign the transaction, no sending transaction, just sign the user operation and send to the bundler. And the bundler is sending the transaction to blockchain and paying gas fee. And then entry point is paying back to the bundler account, and also Paymaster contract getting the payback from the Paymaster to entry point. So this is the basic process of account abstraction Paymaster infrastructure. So we created this bundler and the Paymaster contract and the backend, the smart contract to make it happen, to enable user off-chain payment. And we implemented this function into Scroll L2 and Polygon ZK EVM. And we are thinking the L2, which doesn't have account abstraction in the native layer as a first target. So maybe Stacknet and ZK-Sync having the account abstraction layer in the native layer. So those are not our target. But some L2 doesn't have like optimism on the Outram and Scroll and Polygon ZKM doesn't have the account abstraction layer. So we are going to provide account abstraction bundler and the smart contract and the Paymaster contract to them to enable account abstraction in those L2. So this is our product overview. And I guess there's so many opportunity in this L2 space. So this could be a very good service for them. And also this account abstraction, I just demoed the off-chain payment, but we also we also can implement the social recovery like previous social recovery demo, and also we have a shortcut to the dApps because we have the account abstraction, and account abstraction can do more things like automating transaction or batch transaction. So like you can use account abstraction contract, like you bridge your asset to different chain and you swap the token into different token, and then you buy NFT in the destination chain. So this kind of three transaction you can combine and you can send bundler in the one transaction. So which means so you can automate and you can also send a batch transaction to the blockchain. So this is the benefit of using account abstraction. Okay. So, but I think those benefit of account abstraction may be too much complicated. So first issue I want to fix is about the obstacle to start using L2. So like so many processes we have to do before using L2. But my account abstraction wallet and account abstraction paymaster infrastructure fix this issue. So just pay by credit card, or also pay by payment token, or pay by source chain token. So this is a very significant progress, and this brings easy onboarding to user to start using the L2. Okay, so let me check the overview again. So this is my architecture. So in this hackathon, I built the bundler. So this is the backend which actually send the transaction, and also entry point and the smart contract wallet. And I focus on the paymaster contract implementation. This paymaster contract handling the off-chain payment and depositing and cashback to the bundler contract. So this could be a kind of flexible payment options for dApps. So just now I only integrate to the Wallet Connect sample dApps, but I can also provide more and more payment options like credit card, and also we can use subscription, and also some USDC or specific token for gas payment. So we can have more payment options. And also this could be an API for other dApps to use the gas off-chain payment or payment token, gas fee by payment token payment options to other dApps. So other dApps just integrate my Shinka wallet, and also other dApps can have the gasless transaction in like API integration. Okay, so I think this brings easy onboarding to new users, especially L2, like Scroll and Polygon Mumbai. So this Shinka wallet could be a kind of matching service between L2 and new user. I think this service removes the obstacle to start using the L2 and having more people joining to the crypto space. And this could be a very good use case for new users start using the blockchain. Okay, so thank you. This is about the Shinka wallet.
Thank you. Thank you very much. A quick question is that what do you think is the differentiations for you compared with other existing crypto wallets in the market right now? Like why users will choose your wallet compared with others?
Okay. So actually, my project named Shinka Wallet. So because we just named this name is good, but actually our service is not wallet because our service is about the backend, and our service is about the paymaster infrastructure. So just now I demo using MetaMask, so which means you can bring your own MetaMask or EOA to access this paymaster infrastructure. So this is actually, we are not competing with other wallet. We are just integrating to other wallet. So we are bringing more composability to existing wallet. So now existing wallet can only send transaction by this wallet, but by Shinka wallet infrastructure, this wallet can enjoy the gasless transaction in account abstraction way. So like this is not competing. This is collaborating and bring more composability to existing wallet.
Got it. Yeah, very cool. Thank you very much. Thank you very much for this great pitch. Yeah. Yeah. So I guess that's all for today. Thanks for all three presenting teams today again. For contributing your time and efforts into this demo sessions. You guys all did a great job, and I believe this makes a lot of sense to me, to all the audience in front of the screen, to hearing you to introduce about your project. So yeah, guys, if you have any questions for any of the presenting teams today, feel free to try out their products, join the community, engage with their teams. I believe they are more than happy to know you guys, to communicate and answer your questions there. And also, we have a series of the events like today's in the next few days. I believe there will be at least one more demo sessions for ETHVietnam, and also a bunch of other events from other hackathon grants. So if you haven't followed us on YouTube and you don't want to miss those upcoming sessions and events, please feel free to subscribe our channels. And yeah, thanks again for joining us today, everyone. Hope you guys can all doing great in the future. Keep building. Yeah, and hopefully I will see you guys soon.